Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. We just talked with Matthias Madhu about creating security training that's relevant to what developers need rather than what AppSec teams think they should know. I'm your host, Mike Shima, and I'm here with John Kinsella. It's just about time for the news. But first, do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and we'll reach out to you once reviewed. And join us June 29th for a webcast with Tyler Robinson and Bull Bullock to learn how to pivot into the world of crypto security. Visit securityweekly.com/webcasts to register with only your name and email. Plus, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. So the news this week, John. First, I have to give a good callback to my opening about Star Trek: The Next Generation, which gave us wonderful episodes and phrases like Darmok and Jalad at Tenegra, which if for those of you who haven't seen it, go check out the episode and then think about how that still sounds roughly how InfoSec still explains risk to executive teams. But that's my PSA for the day. And if John has recovered now, we've got some news to talk about, including a new OWASP top 10 list. Which one is this one about?
Oh my God, another one. I can't even find the tab, but that's okay. I don't need it. So when I was digging through various things last week, I saw that there's a new OWASP top 10 list out. And it's funny, I thought there was multiple other ones, but apparently they're more suggestion like SOSA than actual top 10 lists. But this one now is for Kubernetes. And it's what would I call it? Let's sort of pick through a few things they have in here. Supply chain vulnerabilities, lack of centralized policy enforcement, inadequate logging. These things sound familiar to people. Misconfigured cluster components. So some of them are a little Kubernetes-ish, right? Insecure workload configurations. So things which might matter in a multi-tenant cloud or multi-tenant Kubernetes installation. So I'm not trying to blow off this list in any way. I think it's valuable and serves a purpose. And, I think the interesting parts to me, Mike, is you're using something so complex that it needs its own top 10 list, OWASP top 10. And then if you start thinking about, okay, well, does this mean you don't need the standard OWASP top 10 anymore? No, you still need that too. So now you've got two top 10 lists you're dealing with. And I suspect if we start thinking about this a little more, there's probably, I was pondering squeezing in a third one. I decided not to, at least in the show write-up, but you could almost say serverless as well. So if you do Kubernetes and then serverless on top of it, then your code on top of that, it's like, there's a lot of knives you're starting to juggle here. And I think that's the thing to think about. How do you deal with that? It's thinking back to the last segment with Matthias. It's like, okay, well, you've got the app. He was saying about 2% of your team size, so 2 AppSec people per 100 developers. You're going to have some probably separate DevSecOps people too, and then would serverless be separate? So basically, all these different people are going to be looking at this stuff. And I don't know. That's it. As it becomes bigger and more complex, it requires, I think, a lot more intention up front. So that was really the interesting takeaway for me personally.
Yeah, I think we have some other articles coming up that I think will kind of fit into this theme about the complexity and how much do we need this specific security guidance for this domain, Kubernetes, serverless, et cetera. I think the one thing I'd add there is, or two things I guess I would say, is yes, that top 10 list does look familiar. Supply chain vulnerabilities, talking about SBOMs, talking about signing, inadequate logging and monitoring. These are rather universal generic. It's just that the execution now needs to be on the Kubernetes side. And what I will highlight is that OWASP also has a lot of good cheat sheets. And those cheat sheet series has one for serverless, has one for Kubernetes as well. And those could possibly be even the more actionable aspects, if you will. Or maybe those are the more training and execution aspects, if you will, of the OWASP projects, rather of the top 10 to fit into that concept of training like we were just talking about Matthias on. So that's the one I would throw out for that. But we've got now top 10 lists. We actually have not quite 10 vulnerabilities, but we got quite a few vulns. I'll hit on one that's nothing necessarily new, but it was a nice write-up about Ruby vulnerabilities. And here's a write-up from a researcher at Bishop Fox who just walks through some examples of using open and send commands within Ruby to get RCEs. A few things that I liked about this article is that it also linked out to past research. It's showing that, look, this is how I built on other work that people did all the way back to going back as far as 2016 or 2018. And it's really neat to see that type of acknowledgement and basically breadcrumbs to follow on if you're not familiar with pen testing Ruby on Rails, for example. Pick up these pieces, learn about more of the history of what research has been done. So that was a really neat aspect. I think the other thing is that we talked a couple times about bash scripts, and a lot of the vulnerabilities and exploitation in this article relies on knowledge of bash or knowledge of pipes and backticks and tying lots of Unix command line execution together. And so I think it speaks to that idea of know some of the basics of the command line, know some of the basics of bash, and then you can start to learn in just about any language what are those dusty corners, if you will, or those corners that the developers are thinking back, oh, I should probably go rewrite my code because it might not have been secure. And those are some good ways of pulling it apart. So more of just an educational article. That's the type of article that's a neat write-up to read through. So that's why I wanted to highlight that one.
I think it's good to sometimes have reminders of these things. Right? It's we were talking recently. We had the guy who wrote the static analysis tool for Ruby. I can't remember the name of it, but it's good to sort of not just use the tools and do the scanning and those type of things, but occasionally think like, okay, well, what are the sort of standard patterns out there, or what's some of the gotchas which I might have forgotten about. Deserialization, at least personally, is always something I think about when I go to some sort of new thing. It's like, is that one of the things I can actually trust, the deserialization libraries, or do I need to sort of, what type of moats do I need to put around this thing? Riffing on your comment there about, going back and looking at, the shoulders of the giants which we stand on, so to speak, but the going and looking at some of these other research which he's using. There's one thing he did in one of his code samples which I really dig, actually saying, hey, the original code was by this dude, actually mostly based on this URL. This is something I actually do in my code. I've done for a few years. So I've got a shirt around here somewhere I probably weren't on the podcast before of it's a fake O'Reilly book, copying and pasting from Stack Overflow. But we all do it as one way or another, whether it's coming from Stack Overflow or another blog or whatever. But I really like to put a comment by that to say, hey, this is where this is coming from. If, either if there's a mistake in it, or if you're wondering why I did it this way or whatever else, this is something I got from somewhere else. And hopefully when someone looks at that comment in the future, that blog or whatever, it still exists. But I think it's a good habit to get into, to sort of go, hey, I didn't come up with all this amazing stuff by myself. It's not so much taking credit away from what you're doing or anything like that, but half the work we do is not so much writing the code or coming up with the exploit or things like that. It's actually all the steps we had to do just to get to that point. So I think that's good to keep in mind as well.
Oh, very cool. And we haven't talked about the philosophy of what is a good comment versus a bad code comment. But rather than opening that up right now, maybe that's something for the future. I'll just underline what you said there is that's a great example of a good type of code comment, because it's how do you learn more? Or this is the why this code exists. Speaking of code, you've also got some legacy code, perhaps, or not quite legacy code, but some flaws in Google in an OAuth library, I think, within Google, and something about Bluetooth. So a little bit of old, a little bit of new. Which one do you want to hit first?
Let's go to the Bluetooth one, because I think that's sort of fun from a few different reasons. So what's going on here? In a nutshell, modern cars, the key fobs or your phone have this thing in there called Bluetooth Low Energy, which for those not fully up to date in this, BLE is, it has a lot less of the, how would I say, armaments that standard Bluetooth stack has. So you don't have to actually pair with the BTLE device. You don't have to do a lot of the sort of the finicky. The intention is A, it's low energy, and B, it's easier to use. So that like if I want to have my heart rate monitor suddenly work with my phone, I put the two things beside each other, go, and then they just do their thing. So these are being used, at least in the test list, and I think in some other cars, to allow to unlock or to start the car. So as I just said, there's no pairing. So there's no pre-shared authentication, to use that phrase, being loose in my wording here. But what that means is you're able to now do a man in the middle or a replay attack on this, right? At least if you're just trusting the protocol itself for your security. So in other words, what you would need to do to use it securely is actually the responsibility is now yours to build a security stack on top of BTLE. Looks like the folks at Tesla weren't doing that. So what some folks at NCC did is they built basically a relay. So they've got a video here on this post, which shows like, hey, my phone unlocks car. Okay, that's cool. Well, let's take the phone into the office, and then they put it down. I think they said within 20 meters of a relay device, which is going to sniff that, or probably bidirectional, right? But it's going to provide local communication with that Bluetooth device. Then they go out to the car with another device, a laptop with a BTLE emitter, and they're able to relay the unlock from something which is way too far away. And for those playing along at home, this is where you get Faraday cage bags to put your car keys in if you have a car that you don't install. But so that's the core thing of it. Part of the reason I like this particular write-up, I mean, this isn't a write-up, but the blog which links to the write-up, this is on Jalopdeck, standard car nerd site. So I think I like seeing that story, which I just said, in, maybe a little less technical terms, being thrown up on anywhere outside our little world, right? We here at Security Weekly, we spend plenty of time on the blogs, and we got lots of you nerds listening to us every week, but it's good to actually get out and try to, talk outside a little bubble. So I love seeing this article on another site. That's why I linked it directly from here.
Yeah, and speaking of that too, we also said, I think it was last episode or the one before, when it's presentations or conference season, getting outside of the little bubble of InfoSec conferences and talking to developer conferences are great areas to pitch. So here's just another reminder, another suggestion or encouragement for our nerds listening out there to go out and talk to others outside of the InfoSec world and AppSec world. The other thing that was interesting too is there's a tie-in to Matthias's the segment we just had with him, in the sense that he made the comment something along the lines of people misusing the code I write in ways I didn't expect, or they shouldn't have been doing that. Because part of the write-up that NCC Group did here on this, basically the relay attacks within the BLE, is they even point back to the specification that says, we explicitly say that relay attacks are possible. We don't have any countermeasures against relay attacks. So don't protect any valuable assets, or don't have anything valuable that relies on this type of BLE, conversation. So it's interesting just to see the difference between specification known and versus the implementation that says, we want to use BLE for X, Y, or Z that just so happens to have a security context to it, a security boundary to it. And that is something that just documenting, you're not going to prevent that type of misuse. It needs to have something within the technical implementation that says, here is a nonce, random numbers, encrypted, encrypted communication, something that prevents relay attacks. So that's what I'm hitting at there. So good education on this topic.
Yeah. Yep.
There's also, let's see, what else do we have? Also, Rust versus Go, a little bit of more supply chain. We have to get our supply chain bingo square filled out here, John. So let's get that for our listeners.
It's turning into a little bit of a drinking game with supply chain stuff. So we'll have to go sober, I think, for a week or two and see if we can skip some supply chain stuff here in the next month or two. So this one. And this is, I'll be honest, I think this is a little clickbaity, but I think it's interesting for me from the point of view of, so we've seen an uptick over the last, 6 months, I think, or so, where the bad guys, to use that phrase, the technical one, are starting to code their malware in Go. It's a little bit closer to that write once, run anywhere type ideals, since it's a statically linked binary usually. And it's well, I like the language itself, but I'm not using it for malware. But it's so there's value to language. But in this particular case, what's going on is someone figured out to typo squat one of the core libraries or crates in Rust. And SentinelOne's calling this crate depression. But anyways, so long story short, it's typo squatting on a Rust crate. But the interesting part then comes in, they've got a multi-stage attack. So in theory, you would include the wrong crate in your code. That gets checked in and uploaded. And then when it runs, preferably in your CI platform, it goes ahead and it recognizes, hey, I'm running on GitLab, and it downloads from a third party the Go malware, which we are talking about. So that's really the thing, right? I think we've talked about the content here a little bit in the past. If you click through to the SentinelOne article, they do actually go through some of the code. And why I'm mentioning is from the point of view of, if you haven't seen how the kids these days, I can't say these days because I've been doing this for like at least 15 years, but basically how they obfuscate, easy for me to say, a string within the code so that you can't easily read it. It's basically XOR encryption, but it's a decent example of that. And there was a few screenshots and what's going on. So yeah, nothing really, state of the art, at least in my mind, Mike, but
Yeah,
interesting
to see. It's one of those things that it's just this, every language, every package management is eventually going to have these problems of typo squatting, and which is why we are talking about supply chain or salsa, SBOMs, these aspects. We'll get to that, a few frameworks in a moment, but still on the topic of finding vulns in security research, I did grab an article that's probably of interest to many of our listeners, especially on the pen testing side, the security researcher side. The DOJ has clarified their policy around CFAA, which basically says that this is how we're going to interpret CFAA and how we're going to apply it, meaning we're not going to apply it against quote unquote good faith security research, which overall is a good step. But, and there's always a button here, it is just a policy definition. It's not a legislative definition. So the law itself hasn't changed. And, there's still some of that ambiguity around what is good faith research, as much as the original CFAA law has ambiguity about authorized access. And there's been some interesting, in 2021, there was some interesting court cases on that, which I forgot to add into the show notes, but I will. But if you look up Oren Care and CFAA, you'll find a lawyer who has written about computer security, computer crime for quite a while. And I always prefer to go and read what the lawyers say about interpret this because they happen to know the law a little bit better than I do. So I wanted to highlight that article, but I can't necessarily go much more in depth on this. Anything you wanted to add?
Not really. There was a few lawsuits in process. I know there's one big one that got people's attention. I'm happy to see it again thrown out. Basically, this is it's people trying to do the right thing and try and make everything. I mean, particularly the ones they got right. I mean, it's sometimes you will get someone who's a quote unquote researcher and who they're researching, but these were legitimate dudes. Legitimate people. I can't tell you what their sex was, but doing real work, actually trying to help people, and then for them to get caught in the throes of this type of thing is pretty obnoxious. So I'm glad to see that they've taken a step back and reevaluated.
A welcome iteration on that. Switching now from finding the vulns to maybe sort of the defender side of things, maybe the blue team side, if you will. I've got an article about Firefox 100, and Firefox came out earlier this month, but I wanted to hit on this real quick because one of the aspects of this article was that Firefox on the Win32 platform did some additional process hardening, process isolation improvement about applying a new, basically some syscall controls to disable access to some Win32k.sys system calls, which, long story short, a little bit of hand waving is a good thing because it basically says we want to isolate what this process can call into in terms of into the kernel space. And the reason you do that is because we know software is going to have bugs. Historically, all of the browsers have had bugs and 0 days and critical updates. Firefox is not alone. And so in addition to, this is a little bit of my just soapbox, if you will, in addition to rewriting and refactoring into a language like Rust away from our memory unsafe, which is the nice way of referring to C and C++, you can also do architecture changes. And this is a case of rewriting and taking the time to invest in an architecture change on Windows for Firefox to be more secure. So just a good example of different ways to think about writing secure software is a little bit perhaps of a callback to what is secure coding. So I think I've exhausted that, and I don't know my Windows platform very well. So we can go into some frameworks unless there's something you wanted to highlight there.
It's been a while since I've had to do low-level coding for Windows, so yeah. I'm not going to be talking in too much detail about the 132 API. But what I do want to hit on this real briefly is the way they're going about it, right? So it's, you mentioned that they're focusing on what you want to actually, where do you spend those rewrite dollars or refactor, re-architecture dollars? It's also how do you spend them, right? So quick aside. Oh my God, Firefox 100. I remember making jokes to people when I was 26 and thinking that was sort of crazy crazy version. So congrats to them. But yeah, right. I mean, they didn't go Firefox 100. We're coming out with 50 new things which we've rewritten. It's like, no, let's sort of slowly, we see where the goal is. We're trying to get there. Let's sort of slowly move in that direction and do a few commits here and there and improve things gradually. And I think that's, it's something I've been talking to developers about a lot recently, is like, I don't want you to have, which unfortunately I have right now, but I don't want you to have a long living PR that you're working on. Do little tiny commits, right? And just sort of get things going and get things into place. And it's, I guess you could say, I don't think we've talked much about trunk driven development, or just in historically, I'm a very big fan of Git flow. But moving over towards something like trunk-driven development and feature flags, where you get some things in, and then once everything is in place, then you're able to throw the flag and turn them on, or eventually remove the flag. But I think it's especially when you're working with larger teams, I'm starting to drink the Kool-Aid, and I see the value of that. So I think there's things there to be considered, not just the fixing of the security thing, but also how do you go about it? What's the sort of slowly cooking the frog, but also sort of slowly just sort of moving in that without having too much upset to other people. So
well, let's see if we can serve you a bit more of boiled frog or a bit more Kool-Aid, John, by switching to talking about software factories and secure ones for that matter. So here is an aspect of not quite GitOps, although I think I came across GitOps in this white paper. But it's the idea that we as an industry need to build secure software. So we're talking about supply chain. We're talking about, yes, the SolarWinds will, and I have a reason for bringing that up in a moment. But this white paper is nice, I think, because it's at least, rather than saying you should go have a secure CI/CD pipeline, it breaks it down into this is what that might actually look like. We want to have provenance of code. We want to be able to know how and why we trust our code. We want to know how and why, in what ways we're going to enforce the trust in our dependencies. So these things are pretty good. And it breaks it down into those concerns as I described them in terms of provenance, trustworthy dependencies, as well as stages of activity. So you could also just, if you want to target your team, to say, here's our pre-build security concepts. Here's our build environment. How do we want to do security there? Here's our post-build environment that gets into packages, package assigning, things like that. So I think, to me, it does have some good usefulness. It's a meaty paper, if you will. It takes some reading, but it's a framework, I think, to help you, or set up something from the CNCF that's helping those out there to figure out, we don't have anything, what should we do? And rather than have them start from scratch, this, I think, is helping them along the way.
Yeah, and thank you for the media comment. I was working on some sort of a food
Yes.
analogy to keep our little trend going here, and that's us coming up with apple to apple. So I like meaty better. Yeah, if you can't tell, we're hungry this morning. I'm trying to think what I can add of seriousness on this. It's long, it's good. I like the thought process behind it of sort of like say, hey, here's the problem, start off with a diagram or two, this is where we're trying to get to, and then sort of drip down into, okay, how do we go about those various parts? Um, the diagrams look crazy up front. I think they could have rendered them a little better. They seem like they're not, when I make my window bigger, they're not high enough resolution, but that's a small thing. No, it's a good paper by a good group of folks, and we've got another one to talk about here in a few minutes. But it's I think if you are, you hear us talk about SSF and all these sort of things around supply chain and stuff like that. If you haven't actually read something or put like 30 minutes of your week or month into it, this would probably be a good one to read, just because the way they talk about it. It's approachable. With all the appropriate parts glossaries and stuff like that, and a few little pretty pictures. So I would give it a
Yeah, check it
thumbs up
out.
for someone to go
Appendix
and check
B
it out.
has a pretty good checklist of tasks to automate, essentially. And one of the things, though, I like Appendix B, but it also has a column of risks, and in terms of the assurance and the risks, they're pretty much all high or they're moderate to high. So there's a little bit of
Mm.
toughness there in the sense of, well, how do we prioritize? And I try to avoid cliches, but in the sense of, if everything is a P0, then if everything is high, nothing is high, or if everything has the same rating, that's not informative in prioritization. So
Mm-hmm.
it's still a helpful checklist. It's still going to take some work to figure out how are you going to lay out some milestones in a roadmap to getting into a secure software factory on yourself. But this is a good start. And mhm.
But I think that's part of the real quick part of the good thing on it is, right, this isn't, I mean, hopefully we'll get there, but in 2022, probably 2023, this is sort of the state of this type of stuff, right? It's not sort of a, excuse me, not a quick click
Yes.
the button and cool, we're all secure. It takes a bit of work. And that's partially because we all have so many different ways we can do this type of stuff. And there's so many different parts which can be swapped in and out. But I think it's something you got to commit to and try to
Yes,
make little
and
gains every day or
and
two.
ideally commit to as a proactive step rather than the reactive step. If you're in the seat of SolarWinds, for example, who in December 2021 posted their
Mm-hmm.
own white paper on how they did their own secure build system. We covered it at the time, and I really just want to go back to it very briefly, just to highlight that the way SolarWinds described it is they had a distributed CI/CD pipeline, and they had multiple builds, and then they would create a consensus among the builds to figure out, did build A, B, and C produce the same artifact? And if they did, then they're like, okay, this looks like it was secure. Nobody messed with it. And if it didn't, then something went wrong.
Interesting.
What's interesting is that's very clearly a reaction to how they were attacked. In other words, in the build process, in memory, some code was changed. That code was built on a single pipeline, and the package was a nice long nights for many of our incident response teams and developers to go and fix. The SSF that
Mm-hmm.
we're talking about from the CNCF, to overload my acronyms right now, isn't talking about parallel builds and trying to compare these. It's talking about some good, I think, fundamental ways to have a secure software factory that's, I think, informed by what is the design that we would want to see, rather than purely a reaction to a specific type of attack. So wanted to kind of highlight that as maybe not fully, I don't necessarily know the motivations and reading the minds of the different SolarWinds versus CNCF approach, but the outcomes are definitely different, and I think reflective of what they see from a threat perspective.
That is an interesting way to think about it. The first thought in my head is that the multi build and then compare afterwards is that feels like the type of thing you want to do when you're a high value target, which SolarWinds is. But then the question comes back to like how. I'm not saying that like the open the CNCF paper is not for high value targets. So it'd be interesting to sort of read those two and then do a compare and contrast and go, okay, does one have a more secure output than the other? I don't think so. But that might be, it'd be either a good write-up to see one of our listeners put together and we'll feature on the show. Come on, dude, help us out here. Pull request accepted. But that'd be interesting to think about. What does that actually, what is the difference between those two? Is that,
Indeed.
how close
And
are
I think
those
I'll add this
apples to each
because
other?
this is one of the areas that you love talking about is what is also the implementation effort between those two, because I'm going to use my second cliche of the episode. I apologize, but time is money. And investing in multiple CI/CD pipelines or one hardened CI/CD pipeline, they maybe have different trade-offs, but that's an interesting way of approaching this too from a purely engineering perspective as well. So we can now maybe combine that with also talking about V2 of the Cloud Native Security White Paper that the CNCF has been busy. That KubeCon was just last week, and I was reading through a couple of the things that came out of that. But this is a specific white paper that said, we've gone cloud native, but rather than have just that generic term as a reference, here are some good steps about talking about secure configurations, about having security as a design requirement, talking about secure defaults are inherited. And it does, the white paper does expand on a bunch of these topics, but these are a few of the items of guidance that appealed to me in terms of just the principles of software design, if you will. And it does definitely lean heavily into SBOMs, and this is the one that had the GitOps reference that came up to me. In terms of talking about using infrastructure as code, Terraform example as one example, just saying let's put all of the things that we do in terms of our design and management of the environment of a cloud environment into code so that we can lint it, reason through it, analyze it, and so on. So lots of positive things here. Once again, a meaty paper, so take some time to read through it, but I think a worthwhile read.
Yeah, wow. I just downloaded it, to be honest. Like one of the first things I see is version 1 came out in 2020. That feels like a blink of an eye to me since we were talking about the first version of this. And that's sort of shocking. No, I haven't read it, but to expand a little bit upon what you were saying, we throw out phrase around CNCF like, oh, it's those guys, the Kubernetes guys. Not really, but right. But really that cloud native part of that is really sort of taken to heart when they're working on papers like this. So it really is focused around that. And like if you are doing, I just found a typo. If you are, doing something cloud native and you are embracing this sort of set of technologies or this set of using these technologies, then this really is sort of focused for you. And it's, come on, where's my page count? Oh, it's only 55 pages. It's not that bad to read. So, we're really sort of loading you up on the homework this week. But again, it's at least probably worth checking out what's changed. Just going over, it's a pretty good table of contents in here. Just sort of looking at, okay, what is there something I need to drill down into and just look at that area? Maybe come back to the rest of it later. You don't have to sort of attack it as one big sort of meaty salad of.
That's right. There's 178 episodes of Star Trek: The Next Generation and only 55 pages of this cloud security white paper. So, take your pick. Which one do you want to invest your time into? And with that, so that is the final thoughts that I wanted to leave our listeners with. Any final thoughts you want to leave them with, John?
I think I'm good. We did sort of, you hinted at earlier, we've got this in the show notes, Google OAuth has their Java client had a CVSS 8.7 in it. So if you're doing that type of thing, you might want to take a look at that and figure out if that affects you. It really came down to they're not validating the ID token which is coming back as part of the OAuth handshake. So keep that in mind. Take a look, maybe upgrade some libraries, and
there you go.
We'll be talking.
I want to say thank you to John. Thank you to everyone listening. Go upgrade your libraries. And while you're doing that, please subscribe, give us a like, check out the show notes. And we'll see you we'll see you this Friday on a special recorded episode that will release, I think, next week. But it's still going to be Application Security Weekly.